Thank you very much. I'm very happy to be here. Thank you for inviting me. My name is Daniel Szmulewicz. I worked in the industry and now I'm running my own business, a product in the field of e-commerce. I am the founder of the Clojure user group in Israel, and I wrote a library called System, which is a Clojure library which facilitates bottom-up programming. System is a library that aims to make sure that when you do bottom-up programming in the REPL, your runtime state stays in sync with your source code. It aims to provide you a good interactive experience with Clojure. And it leverages three foundational libraries in Clojure: component, tools, namespace, and boot. Boot is a build system. It has no semantics of its own, but by just using these three foundational libraries, it manages to give the user the ability to code in the editor. Every time you save your file, you have current state. Okay? So I'm going to expand on it a little bit later and also do a live demo. I want to announce that this talk is more about programming techniques and human-computer interaction than computer science. It falls in the field of media arts and science, and I'm going to talk about the history of ideas in computer science. Okay. So the big picture here is interactive systems. And there is a spiritual father to interactive systems. Does anybody know who that is? Okay, that's Jean Piaget. Jean Piaget is a psychologist, clinical psychologist, a Swiss clinical psychologist. He was the first psychologist to study the cognitive development of children, how children learn. Okay, and this has tremendous influence on the field of in the field of psychology and much beyond. Notably, it influenced major computer scientists of this century who brought this in their work, and I'm sure that the names that will follow you will be familiar with. So the bridge between Piaget in psychology and computer science is Papert, Seymour Papert, very clearly. He translated the ideas of how children learn into experiments with technology. He showed that you can use technology to teach children or to make them learn, and that was absolutely not obvious at the time. People laughed actually at this notion that you can use technology to teach in the classroom. In the 60s, that was completely far-fetched. Now we take it for granted. Alan Kay is the second person who actually put the final push into making the ideas of Piaget completely mainstream in computer science, because when he developed Smalltalk, he was extremely aware of these ideas, and Smalltalk almost took the world over. I mean, I don't know who remembers this, but Smalltalk was a very mainstream thing at one point in the history of programming languages. Now, this I'm sure everybody knows Abelson and Sussman in their acknowledgements of SIGP, Structure and Interpretation of Computer Programs. It's a extremely clear endorsement of those ideas via Papert, where the key thing here is the understanding that a student's ability to write and modify programs provides a powerful medium in which exploring becomes a natural activity. The key thing here is that you let the user manipulate the program himself, that you let him interact with the system in order to learn. And programming languages have been created wholly or in part for educational use to support the constructionist approach to learning. And again, I will try to explain this strange word, constructionism or constructionist. This is the idea that learning is a reconstruction of knowledge rather than a transmission of knowledge. Okay? So it's not the teacher transmitting knowledge to the students, but the students using his own knowledge to add to that knowledge and construct more knowledge. That is one sense of the word. The other sense is construction. You let the student construct physical things, like tangible things, not necessarily physical, but tangible things, things that can be touched, shared, exchanged, and stuff like that. These ideas, if you think about our domain, I mean, if you think about programming languages and computers and stuff like that, this is extremely abstract. So you don't have physical things to share or to explore. The closest thing that you have, though, is an interactive system in your programming language. That is the door where you can inspect state, where you can debug, you can develop, build on top of what you already have interactively, modify a program while it is running. All those things are the reason why we have interactive systems today, because they make learning and working very, very easy. So Smalltalk was really the ultimate example because it was a long time effort and lots of educators worked on it, and it became extremely mainstream and influential. It also influenced Lisp languages in terms of environments, interactive environments. In particular, the Lisp machine, the interlisp D on the Lisp machine that environment was influenced by Smalltalk. Smalltalk was also, of course, influenced by Lisp because Lisp is earlier, but Smalltalk had its share of influence back to Lisp environments. So just to complete the big picture here, I'm not saying that interactive system appeared only because of ideas from educators. Maybe an interactive system falls off the technical aspect of a system. In particular, you had very early on interactive systems which were non-file based with REPL. That was called workspaces. Forth, which has early implementations were interfacing directly with the hardware, and they were not touching any file system. It was called blocks. And of course, the image of the Smalltalk, which again, not the file-based environment at all. You don't write source. I mean, you don't write a source code in a file. If anybody never had experience with Smalltalk, I really recommend to try it. You can download the distributions of Smalltalk and try it on. You're in the image. You live in an image, and you persist an image, which is the runtime state of your program. Okay, and that's a very different experience, but extremely optimized for interactive programming. So today, again, most of the languages we mostly do file-based development. Almost all languages have REPLs. The Lisp REPL has. This is just for general knowledge. If you're interested in Lisp languages, there is a classic text on what makes the interactive environment or the Lisp experience special in this paper by Eric Sandoval from '78, and he asked what are the properties that we want if we were to develop an interactive story in our programming language. And he mentions stuff like this. I'm not going to go into this because this is not the subject, but he distills this very quickly into a parser, a program printer, an interpreter, or a compiler, which is basically this, which we all know, loop printer, a REPL, basically. Now the thing is that we all kind of have a tendency to think that the interactive story of a programming language is the REPL, but actually it is not enough. A REPL was never enough to build an interactive story in programming language. You need much more. You need an environment, and not all Lisp or schemes come with the same functionality or the same kind of features in terms of interactive story. This is basically the functionality of a REPL, history of inputs and outputs, variables for results, variables to control the reader and the printer, right? Well, what you do when you want to send a snippet of code into the REPL, you need an environment to do that, right? You need much more. So here I have a table with Lisp systems ranked whether or not they come with an environment provided that comes with the language. So IntelliLisp D, Racket, Allegro, and LispWorks all come with a fully integrated environment to help you develop interactively, while the common Lisp or most schemes and Clojure, they come bare bones. They come with a REPL, and the environment comes as a special purpose environment in Emacs, Slime, Geyser, Cider in the case of Clojure. So when you code interactively in all schemes and schemes, the typical workflow is in bottom-up programming is you start with your program with a couple of functions, you build upon it, and when it breaks, when you have an inconsistent state, you restart the process, right? And it's not a problem because the process of your REPL restarts instantly, very quickly. In Clojure, though, it is not the case because restarting the REPL is very costly. It takes a lot of time. Every time you restart the REPL, Clojure needs to bootstrap itself in its hosted environment, and that is very costly. So we don't want to do that. But then we have a problem because many times we get into corners when we in the REPL. Suddenly we have inconsistent state. We have resources that are locked. So you need a discipline. We need to find a solution to this problem. And in Clojure, little by little, the community has come with solutions. Instead of restarting the REPL, we restart the application. So Clojure has built-in facilities to do that, at least reloading namespaces, which are required, and require reload all, which recompiles all the namespaces of your program. The problem is that there are many pitfalls. And this is where I want to be a little bit more concrete. I will do a little demo. The pitfalls are, for example, that if you modify two namespaces which depend on each other, you must remember to reload them in correct order. This is a problem with all REPLs. If you change in your source file definitions that override, you can easily override functions, and you get a breakage the next time you restart the REPL. Def multi is an abstraction in Clojure that also forces you to reload in several places. So I'm going to show here what it looks like in Clojure. Okay, so this is something that is the same in scheme. So if you have a macro that is being used by a function, and then you change the macro, okay? But you forget to recompile your function. Well, you get the old definition, right? But that's not what I meant to do, right? I need to know the semantics of macros. I need to know about expansion time. I need to understand how it works. So this is something an environment can help with. Now, this is not the best example because you might say this is your responsibility. That's your problem if you don't understand about how the macros work. But now I'm going to show another example where it's not that obvious. So this is a protocol in Clojure. And we have protocol P, which defines one method, bar, and I have a type that is, or a record, could be a record or a type, foo, which implements this protocol, okay? Now, I am calling I am instantiating an instance of the type foo, and calling the method from the protocol, okay? So they say that live coding always fails. That's perfect, because I'm trying to show how I can fail. So what am I doing wrong? I'm not in the correct namespace. I have to switch to the correct namespace. So here it is. Okay. So now I want to change the protocol. I'm going to change the protocol instead of. Okay, I just changed the protocol and I get an error, which is completely cryptic. No implementation of method bar of protocol P. Well, that is not true, right? It is there. I have a bar and I have a protocol P. The only thing I did is recompile the protocol. So what is happening here actually is that the implementation of protocols leaks in interactive mode. What happens is that the protocols are implemented in the JVM as classes. My type foo doesn't know any, is not attached to the new class that protocol compiles to, and that's it. That's an error that I'm facing now. Whose problem is this? Like, is this the language designer problem, or the user that needs to know that if he wants to correct this error, he needs to also compile any record or type that implement the protocol to resolve the problem. Okay, so that is definitely something that an interactive environment can solve, and that is basically what tools namespace does. Is every time you you make changes in your source code, it will build a graph of all the dependent namespaces. Remove all the definitions, and then reload the namespace in reverse order, so as to avoid this kind of hiccups when you do interactive development. Okay. The API call to do that in Clojure is called refresh. Now, that was kind of a good solution, because you could spare yourself all these pitfalls when developing interactively, but there is a problem that became apparent, and that is the usage of remove NS. If you look in the Clojure language reference, remove NS has a warning to it. It says, please use with caution, but no more explanation than that. And when I was building my system library, I discovered strange things, and I started to investigate. And I want to share with you what I discovered, also in a live demo. And it has to do with the fact that remove NS doesn't difference any objects in memory. It just undoes a mapping, and everything stays in memory, creating effectively a memory leak. Okay. So I have a namespace called ghost.core with only one definition, a function, pill. Okay. And I'm going to require it. So pill returns blue, okay? Now, I'm going to create an agent which will hold a reference to this var. Okay, and I will send a function to this agent to append the result of what this var resolves to. Okay. What did I do wrong? I forgot the shorthand symbol for function in Clojure. So if I ask what does this var resolves to, a function, right? That is pill. Pill is a function. Now I'm going to ask I'm going to ask the result of that function. Okay. Now I get blue. Okay. Now I'm going to change the value of pill. To red. And I'm going to simulate what happens when you use tools namespace. Tools namespace first does remove an S. Okay, I remove the namespace. Then it does require. It recompiles the namespace. And now I'm going to make sure first that that I get a return that I see red. Okay, that's good. And if I send to the agent who has a reference to the var, what is the result of pill, I still get blue. That's the problem, right? That is actually a quite significant problem, because Vars promises you. What are Vars? Vars is an abstraction that gives you the ability to name things and to reference values, right? Static values. They should not change. Now we have, depending on who we ask, we have one value and another. So the solution for this problem in the interactive environment is to restart all threads every time you make a change to the pill, and which is what a system does. But from a point of view of 30 minutes? Okay, so I'll just come to the conclusion. So removeness is extremely dangerous, as we've seen. It's a question to ask if it is legitimate to use in a library such as tools namespace, which is used all across the board, and which can lead to these kind of problems.
the solution, I think, personally, is that remove NS should result in garbage collection paths. All definitions should be garbage collected, and then we avoid this problem. Okay, thank you very much. Yeah.
I've got a question.
Yeah.
So this is a problem that Clojure REPLs and I guess other REPL systems have had for a long time, and so it's good to see you're tackling this. Going back to the earlier part of your talk, when you were saying that if you want to do true interactive computing, going back to the vision of people in Cambridge,
yeah,
and all that, you need more than small things. Is there?
Yeah.
Is this part of a bigger vision that you have for interactive computing? And once you have fixed the REPL problem, is there something beyond the REPL?
Well, that's
traditionally have.
I'm so happy that you asked this question. That's an excellent question. I think the fundamental problem here is that Clojure leaves the problem. Clojure, the language, leaves the interactive story as a tooling exercise to the community. That is the problem. It does not take any stance. It has dangerous functions inside its library, such as remove NS, and it leaves it up to you. So I don't think anybody from the community can come up and say, I have a vision for a better interactive story. I think this has to come from the stalwarts of the language, because people who have a vision, if they want to do something, they will create their own language. So I really think this is something that should be taken more seriously at the core, with the core contributors to Clojure.
Okay, so what about the folks like Racket who have their own IDE and have control over that ecosystem? Should they be exploring something more radical, more like small talk images or something like that? Do you have a view of what people in the Steam, Lisp, Racket communities could be exploring that would be interesting, novel?
Yeah, I think we have to go back to these old systems and look at them and learn from them, because we have a lot of catch up to do if we compare interactive systems today with the systems like IntelliJ or Smalltalk. But again, that's something that is up to whoever will do the effort. I don't see any effort. Actually, the problem is that people are not aware that the older system was so better than what we're using today. So that is the real problem. The problem is education. The problem is enlarging the knowledge of what are the ideas in computer science, what kind of ideas we had, the history of computer science. Because when you learn computer science, you generally don't learn about the history of computer science, neither about the philosophy of computer science. If you want to know these things, then you have to do some course in interactive media, in science and philosophy of computer science. The problem is that people who make the systems are not aware, or not always aware, of what has been done before and what we are missing today. And that is actually, I think, the problem. Yeah.
So we have to I think there's some inherent limitations in any approach to this problem that deals with removing things from the heap and reconstructing them in the new way.
Exactly.
Mm-hmm. For example, if I've got my process to a certain state and it has a whole bunch of connections to various external, it's got a socket open to a database and who knows what, I may not want to just shut that down because it might be very costly to bring it up again because it needs to do a lot of computation or external communication. Whereas, and this is part of the limitation if you look at the adopter Racket, where if the way you maintain everything up in sync is when you edit your definitions and you push run again, it throws everything away and starts from scratch. And so sometimes you've got the wrong paths there. So I'm wondering if you have any thoughts.
Yeah, well, I think that's also an excellent point that you are raising, and it is indeed a hard, sometimes tough decisions that needs to be made. But in terms of what Clojure did, I think the reason we have a function called remove ns is because if you look at a class which creates the namespaces, it's a typical Java class where you can create a namespace and therefore you can also remove the namespace. But what it does actually is just when you create a namespace, it creates an entry in a hash table. It's just a mapping, and when it removes the namespace, it just removes that entry from the hash table, and that's it. There is absolutely no meaningful unloading of code. And I think what needs to happen is you need to if you build a runtime, you need to collaborate with the garbage collector, and you need to make sure that whatever you do results in the garbage collector kicking in, and so dereferencing everything that you know that exists that needs to be dereferenced. Yeah.
Do you have time for one more?
Yeah.
Sort of similar question, but I'm not sure what was the point of getting the IDE instead of just, let's say you were using the Emacs, and if you, let's say, rewrite the certain part, and then if that Emacs is small enough to detect all the dependency and just reload everything, then I thought it was done. What would be the difference behind your philosophy and this sort of probably works solution?
Well, can you actually repeat the question, because I'm trying to see if, because I agree with what you say, so I'm trying to see what do I miss? Yes, the ID needs, yeah.
Basically, you said your philosophy, the language itself should contain the development environment, which needs to be very smart. Then otherwise, people would create a new language which might be smarter than the programming language A. And what if there's the smarter Emacs script which actually takes that file and then reload this file and then detect all the dependency, the current dependency,
So,
and reload everything.
Okay.
Restarting the JVM. What would be the difference between this solution and your philosophy?
Are you asking if you could get the same kind of intelligence in the Emacs IDE than as a special purpose interactive environment? Is this what you're saying?
Yes.
So I don't care at all. For me, it could be actually I'm an Emacs user, and I would prefer to see this intelligence inside a special an Emacs add-on like Cider could be. I don't care from where it comes from, as long as I have a good interactive story. As long as when I start doing bottom-up programming, I kind of get a sane workflow. That's what I'm saying. And today it is very difficult, at least in Clojure, if you don't know where to look. You don't, out of the box, Clojure doesn't give you an interactive workflow. Just give you a REPL, very basic, with lots of pitfalls. If you start, that is a problem. If you're an expert, if you've been active in the community for a while and you know where to look, then you will understand, okay, this is a place where I can get good tooling. And so you have Cider, and you have tools.namespace, and you have system, and you can build your. This takes a lot of time. If you look at the IRC channels, lots of people are struggling with how do I get my workflow? How do I set up my workflow? It can take months before somebody feels comfortable in his Clojure workflow, just because it's so difficult to find the right pieces.
We should thank the speaker again.